Welcome to this video on the topic of simultaneous equations. In this video I'm going to show you a technique called elimination, which we can use to deduce the values of unknowns in a set of equations. Now the way in which elimination works is we either add, subtract, or in some cases divide two equations together with the intention of removing or eliminating a term from the equations. Now looking at example 1 here, we've got 4x plus 3y equals 10. That's our equation 1. And then we've got x plus 3y equals 1. That's our equation 2. Now what we're going to do here is we're going to subtract equation 2 from equation 1 with the intention of eliminating the term 3y. So what that's going to look like is I'm going to draw a bar underneath these two equations here. I'm going to draw a minus symbol to denote I'm about to do some subtraction. Then I'm going to write 10 for x and then plus 3y. So that's my first equation written down. Now I'm going to subtract my second equation from my first equation. So on the right hand side here I'm going to go minus 1. Then I'm going to go minus x. I'm going to go minus 3y. So I've taken my second equation away from my first equation. Now collecting like terms, on the right hand side we've got 9. Over here we've got 4x take x is 3x. Plus 3y take 3y, well that's nothing. Cleaning this up, 3x equals 9, and therefore x is equal to 3. So this process here, this is a process called elimination. So we've subtracted two equations from one another, and in the process removed one of the terms. Now to finish this off, we need to deduce the value of y. Now if we wanted to, we could do elimination once more to solve for y, but the reality is when we're doing math here, we simply want to find the value of y using the easiest route possible. So in this case, I'm just going to use substitution again. So I'm going to go x plus 3y equals 1. And I'm going to say, but x equals 3, therefore 3 equals 3y equals 1, 3y equals minus 2, y equals minus 2 divided by 3. So our two solutions here and here. Okay, so that's a nice simple one. Let's go down and let's have a look at example 2. We've got 4x plus 3y equals 2. Sort of similar to what we saw before. This is our first equation. And then we've got x minus 3y equals 8. This is our second equation. Now, what we want to do here is, once again, we want to try and eliminate these terms in here because notice there's a 3y and a 3y. So the coefficients are the same. So if we merge these two equations together, the 3y's, they're going to cancel out. But what's different in this case is if you observe in the first equation, both of these were plus. In this case here, we've got a plus and a minus. So what's going to happen is if we take equation 2 away from equation 1, the two 3's, they're going to stack. We're going to get 3y take minus 3y, which will be positive 6y. So we'd end up with a new equation that still has two unknowns. So rather than taking the equations away from one another, what we're going to do is we're going to add these two equations to one another. So this is going to look like So I've done the pluses all in red here to emphasize what's going on. So we've got 4x plus x plus 3y plus minus 3y. Then on the right hand side we've got 2 plus 8. Then we simply collect like terms. I'm going to get a 5x here now. Then we've got 3y plus minus 3y. Well, it's nothing. Then we get 5x plus or equals 10. Therefore, x equals 5 divided by, or 10 divided by 5, which is simply x is equal to 2. Nothing to it. So that would be a solution for x. Now we need to find the corresponding solution for y. So once again, we go for substitution. Therefore, the value of y is equal to minus 2 in this case. So difference between example 1 and example 2. In example 1, we took the second equation from the first. In example 2, we added equation 2 to equation 1, both with the objective of cancelling out the terms involving y. Okay, so this seems like a pretty decent method thus far, but consider what's going to happen if we have, say, example 3 here. In example 3, we have y equals x plus 5. That's our equation 1. And then for equation 2, we've got 3x minus y equals 1. So equation 2. The problem thus far we have is, notice that these equations don't line up. So the first thing we need to do to be able to employ the method of elimination is we need to line these equations up such that we can apply elimination. So the terms have to line up. So we've got y equals x plus 5. We'll go y equals x plus 5. So this is still equation 1. What we need to do is we need to rearrange equation 2 such that it's going to be in this form. So the leading term needs to be y. So I'll grab, moving over here, 3x minus y equals 1. I'm going to rearrange this such that y is the subject. So I need to move this x over to the other side. So I go minus y, 1, take 3x, and then I need to swap the 1 and the 3x around. So we're going to go minus y equals minus 3x plus 1. And I could leave it in that way, but it's a little bit messy. So what I'm going to do is I'm going to times both sides of this equation by negative 1. So we're going to get y plus or equals positive 3x, take 1, like so. And this is still equation 2, just in a different form. So writing that out, we've got y equals 3x minus 1. Alright, now we need to think about what term do we want to eliminate here. Now if we look at the y's, they're both equal, they've both got a coefficient of 1. So this is a good candidate. We have the x's, but one's a 1x and the other one's a 3x, so that's not a very good candidate. And there's no point eliminating the constants because that's not going to lead to anything useful. So what we'll do is we'll eliminate these y's. To eliminate the y's in this case, because they're both positive, we have to subtract equation 2 from equation 1. So this is going to look like y x plus 5. We're going to take, it's our operation, take y, take 3x, and take minus 1, like so. And that's equals that. Now simplifying this, y take y is nothing, x take 3x, that's going to be minus 2x. 5 take negative 1, that's positive 6. So now we've got 2x, negative 2x plus 6, 0. Rearranging constant or terms go on the left, so variable terms go on the left, so that's positive 2x now. equals 6. Dividing both sides by 2, x is equal to 3. So point of this exercise here is if the equations are in differing forms, then we need to line all the terms up, which can involve some rearranging as seen over here. Alright, let's finish this off using substitution once again. We're going to go y equals, we pick the easy one, x plus 5. And we'll say, but x is equal to 3. Drop the 3, add the 5. Therefore, y is equal to 8. Nice and easy. Alright, example 4 now. 4x plus 2y equals 7. This is our equation 1. And then we've got 2x minus 5y equals 11. This is our equation 2. Okay, so what we have here is we've got terms here x. So we've got a 4x and a 2x. Terms here for y, we've got a positive 2y and a negative 5y. And we've got these constants 7 and 11. What we need to decide is which terms do we want to cancel out. Now, if we look at the x terms, neither of them match, and the same is with these y terms. So this is a new problem we are faced with. Now, to find the solution to be able to use elimination here, we need to make it such that either the x terms are the same, or we need to make it such that these y terms are the same. Now, looking at the y terms here, notice that we've got a 2 and a 5. They're both prime numbers, so it's pretty hard to make these guys the same. You can do it, but it's messy with the fractions you deal with. And similarly, we've got 4 and a 2. 4 and 2 there, they've got a common factor in terms of here. So I think we'll make these two the same. Now, what I'm going to do is I'm going to grab equation 2 here. And I'm going to go 2x minus 5y equals 11. Still equation 2. And what I'm going to do is I want to change this to a 4x. And the way in which I can do this is I'm going to multiply both sides of the equation by 2. Like so. Then this is going to give 4x here minus 10y minus 22. So I didn't change the values of the equation. I've simply changed the form of which it's presented. So I haven't broken or changed anything here, only its form. Alright, now going back, we have for equation 1, 4x plus 2y equals 7. Then for equation 2, we've got 4x take 10y equals 22. Now, because we've got these two 4x's here, we're going to go for subtraction. Still equation 1, equation 2. And writing this out, we're going to get 4x, 2y, and 7. It's still the equals, we're subtracting. Then we've got 4x, still a plus there. Then we've got minus 10y, minus 22. Alright, so we've taken equation 2 from equation 1. This is going to give us 7 take 22. I believe that is minus 15. 4x take 4x, that's nothing. And 2y minus negative 10y, they're going to stack. So that's 12y. Now, to solve this, we have to divide. We'll clean it up first. We'll go 12y minus 15. And then we're going to divide both sides of the equation by 12. So we're going to get minus 15 all over 12. So a little bit messy there. We can simplify it actually. So we'll go, common factor is 3 in this case. So we're going to get minus 5 on 4, like so. So that's our value for y. Now going back and solving for x, we can grab 4x plus 2y equals 7. But y equals minus 5 on 4. This is going to become minus 5 on 2. 4x. Moving the constants to the right hand side. Changing the 7 to a fraction with a common denominator, that's going to be 14 on 2. It's getting a little bit messy, but just persevere. Then we're going to get 14 plus 5. That's going to be 19 on 2. It's getting really messy. And then we're going to divide both sides by 4. So it's effectively the same as timesing it by a quarter. So this is going to be 19 on 8. From this part here, you just use your calculator. Just use your calculator for fractional arithmetic like this, or else you'll easily make a mistake. So this would be the solution in this case here. So going up, for example 1, to solve these, notice that we've got a corresponding set of terms. So they've both got the same coefficient. So in this case, we can just subtract the two equations from one another to create a third equation with a single unknown. For example 2, we have two equations. We've got similar coefficients in that they're different polarity. So one's positive, the other's negative. We add the two equations together to eliminate the single term. For example 3, to solve this equation, we simply have to rearrange both equations such that they are in the same, or the terms align with one another. So the variable terms all align, so we can either do a subtraction or addition. And then for example 4, we have to change, or we have to multiply through one of the equations to make it such that at least one of the terms correspond to one another. In this case, we picked the x's, so we multiplied the second equation by 2 to make this 2x equal 4x, which would be the same as this equation 1 here.